What's up, 10C? Got a video here today on looking at domain and range and talking about interval notation. Again, if you're trying to follow along in the NOPAC, this information is on pages 12 to 18, but it's a little bit different than is in that NOPAC. If you have not watched the first video on domain and range, talking about the introduction, looking at some vocabulary and how to express domain and range in words, stop this video right now, go watch that video first before you watch this video. So a quick review from that video, some things to talk about here. So if they said, here's this graph, I want you to explain or talk about the domain and range of these graphs here. This graph right here is discrete data. And so if we need to talk about the domain and range of this graph, what we need to do is anytime we have discrete data, we list off the value points. So for domain, I'm going to list off all of the x values that these points occur at. So this is 1, 2, 3, 4, 5, 6. That's all of the x values that these domain points occur at. 6. Close that. For the range, well, the range is what is all of the y values of those points. So I'll start down here. So we got a point at -1. Here is 0, 1, 2, and 3. Here, 1, 2, and 3. So for discrete data, all we need to do is list off those values for the data points. Another review here, I want to talk about the domain and range and for a continuous graph and how we can represent that in words. So for the domain is talking about all of the possible independent variables of a graph. And now the other word that we talked about, independent, also means x values. So what are all of the possible x values on this graph? So if I'm following this line, how far to the right can I go? Well, this graph is continuing up and over forever. So how far right can I go? Well, technically I can go to the right forever in this direction. Well, now let's go to the left. How far left can I go? So how far can I go negatively on this x-axis? Now the same thing is happening here. This graph is going to go up and over forever. So how far to the left can I go? I can go to the left forever, or what we would call infinity. So to express that in words, I just say the domain is all real numbers, which means I can be any number that we know is part of the real number system, is all real numbers. Let's do the same thing for the range. Well, how high could this graph go? Well, we said this graph is going up forever, so I could be any y value way up here. So I could be any y value here. How far down can I go? Well, the lowest y value occurs right here, and it looks like it occurs at about -6. So if I want to write that in words, I start off with the range is, I always say all real numbers because this is a continuous line, so the range is all real numbers. Now we're looking at what's happening compared to this -6. So we are all real numbers over or higher than -6. So we say the range is all real numbers greater than. And I want to know if I can equal -6. Well, what we're going to assume happens is this graph comes, it touches -6, and then it goes back in the other direction. So we're going to say greater than or equal to -6. And so that's how we express domain and range in words. Today we're going to take a look at a different way of expressing domain and range, which is using words, using interval notation. And so interval notation is used to express a set of numbers between two values A and B. And we use symbols or brackets to help us express what's happening between that interval. So as a very generic kind of code that you can substitute into here, what we do is we go right on the left side, we put some sort of, this is a bracket. And what we do is we go something, comma, something. So they're saying A and B. I like to say the other way is, well, you're going to put the lowest number here, and then you put the highest number. So it's the lowest number you could possibly be, comma, the highest number you can possibly be. And so you're saying you're an interval within that range. And then you have to have a bracket on either side of those numbers. Now, what kind of brackets do we have? We have two options for brackets here. We have a curved bracket, which is used for less than or greater than. The brackets means, if I use these brackets, that means that number is not, I cannot equal whatever number I put there. So if I said, it's 5 comma something, that would mean I could get as close to I could as 5, but I can't equal 5. The other type of bracket is this square bracket, and I can use a curved bracket and a square bracket in the same question. So a square bracket is used if you can be less than or equal to or greater than or equal to a number. And that means those values are included in the data points. So I'm using these square brackets if we can equal a number. Now, how can we tell if we equal a number? Well, we can equal a number if you have a closed dot or if the graph bounces off that value. Okay. And just to go back up, so a curved bracket means we cannot equal that number, which would be like an open dot. And there's another reason we'll use curved brackets that I'm going to talk about here in a second. Okay, so the other type of thing that we're going to add here to interval notation is the infinity symbol. So that little kind of sideways 8, right? This is called the infinity symbol. And we use it when there is no upper or lower bound on the number. So if you can go forever and ever and ever in a certain direction and there's no capping value to it, we say, you could go on forever. So in mathematics, that's infinity. So for example, if I'm looking at this right here, what are they saying? The x value. Well, the lowest x value I could be on this graph is -5. And it already says here, but this graph is going to go over forever because this is going down and over, down and over, down and over. So I could technically be any value this way, which is infinity. Now, to come back here, we have to always use a curved bracket with infinity because a curved bracket means you cannot equal that number. And so you cannot ever equal infinity because if I say, well, infinity plus 1, right? That number keeps going. So we always will use a curved bracket if we have, if we're dealing with infinity. So I have a few really basic number lines here that I want to examine, and we'll use the interval notation for this, and then we'll go look at some two-dimensional graphs here. So here we have a number line, and I should be able to look at this question here and say, okay, let's say we're talking about the domain. So we could say x, based off this, is greater than or equal to 3. That's what, if I'm reading this, x is greater than or equal to 3, because I can be any number in that direction. Now what I want to do is take those and substitute it into that interval notation. And so here we got to put a bracket, a lower number, comma, a higher number, and another bracket. So lowest number, highest number, and this is a bracket, and we want to go substitute some values into there. So let's go ahead and do that. So for this one, x is greater than or equal to 3. Well, what's the lowest number we can be on this number line? Well, the lowest number we can be is 3, comma, the highest number we could be, well, if it just goes over and over and over, that means we can go all the way up to infinity. So to represent this in interval notation, it's 3, comma, infinity. The last thing we need to do there is add brackets. Now, we use a square bracket if you can equal a number, and a curved bracket if you cannot equal a number. So can I equal 3? I can equal 3 because this is a closed dot right here, so I'd have a square bracket, comma, infinity. You can never equal infinity, so I put my curved bracket there. Okay? Let's take a look at the next one here. Change my color. So here, if I was to express this and read this out, I would say that, we'll say again, x is, well, what's happening here? Are we less than 3 or greater than 3? Well, we are less than 3, less than. Can I equal 3? No, because this is an open dot. So x is less than 3. Now let's go ahead and express that word form in interval notation. So I have to go the lowest number, comma, the highest number. Well, what's the lowest number I can be over here? Well, technically, if that line just keeps going forever and ever and ever in the negative direction, we call that negative infinity. Comma, the highest number I can go this way is really close to 3, but I can't quite equal it. Now I just need to put in my brackets there. So the bracket, I cannot equal infinity, so a curved bracket, and I cannot equal 3 because this is an open dot here, so another curved bracket. Okay, I'm going to ignore those next 2 questions. So here is a graph that we looked at previously in the other video, and we had already expressed this in words. And so from the previous video, we said domain is all real numbers between -4 and 3, not including 3. So that's saying, you know, you can go all the way to 4, or -4, I can equal that number, and then I go all the way up on the x value, I can go up to 3, but I cannot equal 3. Now we want to express that in interval notation. So it's always the lowest number, comma, the highest number. So the lowest number I can be on my x value is -4, and the highest number is 3. My domain is completely restricted by those. So now I just need to add my brackets. Can I equal 4? Yeah, I can equal 4 because there's a closed dot right here. So I'd use a square bracket. I can go all the way up this line, but can I equal 3? No, because it's an open dot, so I'd have a curved bracket there. And so there is my domain expressed using interval notation. Next one says, for expressing the range is all real numbers between -5 and 4, not including 4. So they're saying, you know, you can go all the way down to 5 here, and you can equal it, and you can then go all the way up to 4, and we can't equal that number. But I want to express that in interval notation. I'll start with the lower number, which is -5, comma, the higher number. How high can I go up on my range? I can go all the way up to 4. So -5, can I equal that number? Yeah, because it's a closed dot, so I'll use the square bracket, comma, the higher number, which I can't equal that, so I use a curved bracket. And so there is the range expressed in interval notation for that function. Just did that one, so let's do a few more here. Interval notation, so let's talk about the domain. We already talked about this in words, but I'm still going to go through them. So we said, well, how far can I go to the right here? I can go to the right forever. How far can I go to the left? I can go forever. So expressing the domain in words from the previous video, we said the domain is all real numbers, because I could be any number in the real system because that graph goes to the left forever and the right forever is all real numbers. Now I want to express that in interval notation. So I need to go the lower number, comma, the higher number. What's the lowest possible number I could be over here? Well, it's going to keep going left and left and left forever, all the way to negative infinity, comma, the higher number. Well, how far right can I go? I can go to the right forever. So that's going to be a positive infinity. I don't need to put the positive with the infinity sign there. My last thing for interval notation is to put brackets. I cannot equal infinity, so these guys would both have curved brackets on them. The range. The range is going to, what's the lowest possible value this graph could be on the range? Like, can I be a value down here? No. We're going to assume that this graph comes, it touches 0, and then it bounces back up the other direction. So here's 0, and then it's all the numbers above, or we would say all the numbers greater than that value. So the range is all real numbers greater than, we would also say equal to, because we assume we touch 0 and then bounce in the other direction. If it ever bounces off a number, you always assume that you can equal that number. So the range is all real numbers greater than or equal to 0. So now I need to put that to interval notation. Lowest number, comma, highest number. The lowest number we can come down on the x value is right to this 0 point. So 0, comma, the highest number, well, this is just going to go up forever, right? The graph's going to go over this way and over this way, so I can do any y value way up here, which gets me to infinity. Can't equal infinity, so a curved bracket here, and again, we assume that we touch this value and we go in the other direction. I can equal 0, so I'll have a square bracket there. Last example here, so solve using interval notation. Let's start with the domain first of all. How far right can I go? Well, again, we're going to assume this graph just keeps going up and over forever. So how far to the right can I go? I can go to the right forever because that graph's going to go up and right forever. How far left can I go? Well, if I follow down this graph, I can only get all the way to this point. So the corresponding x value there is, excuse me, -2. I need to express that in words. So the domain, because this is continuous, we always start with the domain is all real numbers. And I'm going to say greater than. I cannot equal -2 because that's an open dot. So the domain is all real numbers greater than -2. Once I understand that in words, I can then put that into interval notation. Lowest number, comma, highest number. So the lowest number we can be here is -2, comma, the highest number, it goes forever to the right. So that can go all the way to infinity, that function. Can I equal -2? No, because it's an open dot down here. Can I equal infinity? No, so I put the curve brackets there. Now I'll do the range. So what's the lowest number I can be down on this graph? Well, the corresponding y value at this point is -3. How far up can I go? Well, we said this graph goes up and over forever, so this is just going to keep going forever and ever up because I can find any corresponding y value up here. So to express that in words, the range is all real numbers greater than -3. Please don't assume because this is greater than, you kind of always have to look at the individual function and figure it out. As well as whatever brackets are used here are not always the same ones that are going to be used here. You have to look at it on an individual domain and range case-by-case basis. So to put this in interval notation, the lowest number, -3, comma, the highest number, well, we can go up forever, so we put infinity. Can I equal -3? No, because it's an open dot there. Can I equal infinity? No, so I put 2 curved brackets. Okay, so that is the lesson for interval notation on domain and range. Please go ahead and try that Desmos activity on interval notation. It should take you about 10-15 minutes. Again, it's not for marks. It's just to see that I can see what you understand, what you don't understand before you have to go do some quizzes and to see if I need to help in any other way. All right, thanks for listening. Have a good one.